All right, last example is going to be a little bit more complicated, but again, we just have to make things just one more step more complicated so we can kind of get to the answers more easily, just step by step. We're going to start with an inequality. We're going to try and solve that inequality or set the inequality such that we've only got one variable, or that variable is equal to, the variable is 1 times the variable on the one side of an inequality. From that inequality, create a number line. From that number line, set up our interval notation by saying, what's the border on the left? What's the border on the right? Do we include the border on the right or left? If we do, square bracket. If we don't include the border, round bracket. So a couple of examples that we're going to go through just slowly that we've done before. We're going to get to something, because so far we've kind of solved simpler inequalities. But now we got something that's maybe a complex or more complex inequality. Something like maybe 3 less than 3x less than or equal to 12 maybe. So there's an inequality we could maybe see. And that would be probably the one of the more complicated ones. We could maybe add 3x minus 7, something like that. But that would be the next step. But essentially, all we're doing is solving this inequality for just having that x by itself in here. So if we've got 3 different parts of our inequality, we've got to basically treat each part of that inequality the same. I have 3x here, and I don't want 3x. I want just x by itself. So I've got to divide by 3 here in the middle. But if I'm dividing by 3 here, I've got to divide by 3 over here, and I've got to divide by 3 over here, because we've got to treat each of these columns equally. All right, on the left then, 3 divided by 3, 1. In the middle, 3x divided by 3, 3 divided by 3 is their factors. They factors cancel, reduce, simplify, factor out. 3 divided by 3 is 1, or just x. On the right side, 12 divided by 3 is 4. I didn't talk about the inequalities yet, just because I wanted to make sure that I didn't have to change the direction of the arrow. We're dividing by a positive number, so therefore we don't have to worry about changing the direction. Dividing by a positive number, don't have to worry about changing the direction, and the inequalities kind of just remain the same. So here is we started with 3 less than 3x less than or equal to 12. We divided by 3, and we got to this inequality. Now, from our inequality when x is just 1x, just by itself, now we can set up our inequality number line, or a graphing number line. X is trapped between 1 and positive 4. So x is greater than 1, so my border over here has to be 1. My border over here on the right has to be 4. And the solution set is all these numbers in between. And what do we do with the border? Well, x could be less than or equal to 4. So because it could be equal to 4, put a square bracket right there. X is greater than 1, or 1 is less than x. So therefore, x cannot be equal to 1. So we put a rounded bracket there. From the number line, we can find that 1 is our border on the left, positive 4 on the right. We include 4 in our solution set because it could be equal to 4. The bracket tells us that we've got to use a square bracket there. Rounded bracket here tells us rounded bracket in our interval notation. Comma between our borders, and we're done. There's our interval notation. So essentially, if we've got an inequality, set up our borders and do we include or not include the borders, and then from our number line it's easy to set up our interval notation. And there's our interval notation.